Hello everyone, welcome back to our channel. Today we are going to discuss about semiconductor electrons, very short answer questions. This is very important, compulsory. One VSAQ and one SAQ is coming to the board examination. So what is the role of semiconductors in our daily life? With the help of the semiconductors only, we are making that electronic devices, few electronic devices like switchboards are there, transformers, then the memory cards. That one we are using the germanium and silicon materials. These are nothing but semiconductors. So based on the electrical properties, that solids are classified into three types: conductors, insulators and semiconductors. Conductors means free electrons are available. In insulators there is no free electrons, but these semiconductors lie in between the conductors and insulators. Then semiconductors are classified into two types. One is the intrinsic semiconductor, another one is the extrinsic semiconductors. What are the intrinsic semiconductors? Semiconductors in pure form are called the intrinsic semiconductors. What are the examples for that? Germanium and silicon. Then what are the extrinsic semiconductors? Semiconductors in impure form. We are taking pure semiconductor, we are doping with some impurities, then we are getting the extrinsic semiconductor. But come to our very short answer questions. In this, what is the first VSAQ here? First one is, what are the n-type semiconductors and what are the majority and minority charge carriers? What is n-type? How you are getting? Just now I said intrinsic semiconductors. We are taking one intrinsic semiconductor that is doped with pentavalent elements. Okay, so it is having the 5 valence electrons. When it is doped with pentavalent elements, then pure semiconductor becomes to n-type semiconductor. So here excess electrons are available. So majority charge carriers in n-type semiconductors are the electrons, then minority charge carriers are the holes. So this is the n-type semiconductor. So in examination you should write it. When pure semiconductor is doped with pentavalent element, that is called which type of semiconductor? N types of semiconductor. The next thing, majority charge carriers are the electrons and minority charge carriers are the holes. Then our second VSAQ is, what is the PN junction? Second one is the like that p-type semiconductors. What are the p-type semiconductors? So here like that we are taking pure semiconductor that is doped with trivalent elements, then it is called the p-type semiconductor. Here this is not having the lack of electrons, nothing but, so holes are the majority charge carriers and electrons are the minority charge carriers in p-type semiconductors. Then our next question is, what are the intrinsic and what are the extrinsic semiconductors? Already you know that pure form of semiconductors are the intrinsic semiconductors. Impure form of that semiconductors are called the extrinsic semiconductors. Then our fourth question is, what is PN junction diode? Our fourth question is, what is PN junction diode? So we are taking one pure semiconductor. Half is doped with p-type material, another half is doped with n-type material. So it has two terminals. One is here majority are the holes, here majority are the electrons. Because of this diffusing of charge carriers, here one junction is formed. These are the electrons and these are the holes. This is the depletion layer and this is the potential of depletion layer. But our question is, what is the PN junction diode? We should write it. It has two terminals. Pure semiconductor doped with one side p-type, another side is the n-type. We are getting the PN junction diode. But what is the symbol for PN junction diode? This is the symbol for PN junction diode. This is the symbol for PN junction diode. Then our fifth very short answer question is, how is battery connecting in forward bias and reverse bias? First of all, what is the forward bias and what is the reverse bias, and with the help of that is one of the application of the PN junction diode. Forward bias means, look here, it has two terminals. One side is the P, another side is the N. Forward bias means this P is giving to the positive terminal of the battery and N is giving to the negative terminal of the battery. Here if you want to use, we can use 1 milliampere also for measuring the current. So our answer is just P is giving to the positive terminal of the battery, N is giving to the negative terminal of the battery. That is called the forward bias. But in forward bias, what happens? We are applying the potential difference. It is dominating the junction depletion layer potential. Then charge carrier's movement is there. It is acting like switch on condition. Then in this question B is, what is the reverse bias? Reverse bias means reverse of that one. P is giving to the negative of the battery, then N is giving to the positive of the battery. Here if you want, we can use microammeter also for measuring this. Here the width of the depletion layer is increases. Why? All holes are attracted by the negative terminal and all electrons are attracted by the positive terminal. Here width of the depletion layer is increases. It is acting like a switch off condition also. So this is the 5th VSAQ. Then come to 6th VSAQ. What is the maximum percentage of rectifier in half wave and full wave rectifier? See, one more topic in this chapter is rectifier. Rectifier means it is converting alternating current to the direct current. There are two types of rectifiers, half wave rectifier and full wave rectifier. So in half wave rectifier, what happens? Only half of the alternating current is converting into direct current. That's why that is the half wave rectifier. But in full wave rectifier, what happens? Complete alternating current is converting to direct current. But the question is, in this we have to mention the percentages in both half wave rectifier and full wave rectifier. For half wave rectifier, just you should mention that percentage is 40.6%, and full wave rectifier it is 81.2%. 81.2%. Then our next question is, what is the Zener voltage and how will a Zener diode be connected in a circuit? See, Zener diode we can use as a voltage regulator also. What is Zener diode? It is having the, when we are taking the PN junction diode, and it is having the sharp breakdown voltage when it is connected in reverse bias. That is called the Zener diode, and that voltage is called the Zener breakdown voltage also we are taking. Then how it is connected? Always in circuit it is connected in reverse bias. Even it is connected in forward bias, it is acting like a PN junction diode only. There is no extra characteristics of that one. So that is the 7th VSAQ. Then 8th VSAQ is what write the expression for the efficiency of full wave rectifier and half wave rectifiers. When we are going through the full wave rectifier efficiency is eta equals to 0.812 RL by RL plus RF. Here RL is the load resistance and RF is the forward resistance. Like that, in this case B, half wave rectifier efficiency is 0.406 RL by RL plus RF. So just we should mention the what is the efficiency of full wave rectifier and what is the efficiency of half wave rectifier, we have to find out. Then in this 9th VSAQ is, what happens to the width of the depletion layer in a PN junction diode when it is forward bias? Already you know that in forward bias width of the depletion layer decreases. Then in reverse bias width of the depletion layer is increases. Enough this much. Then 10th VSAQ is, 10th very short answer question is, draw the circuit symbols of PNP and NPN transistors. So like rectifiers, we are using the transistors also. There are two types of transistors. One is the PNP transistor, another one is the NPN transistor. Always we should remember that it has three parts. One is the emitter, base and collector. See, PNP transistor, just we should mention the symbol. Most of the people are confusing. This is the base and this is the emitter and this is the collector. This is the collector. If the arrowhead is towards the base, that is called the PNP transistor. Like that, NPN transistor is NPN transistor. This is the base, emitter, collector. This is the base, emitter. This is the collector. Here arrowhead is away from the base. So this is the NPN transistor. It's very important. Many times they were asking this question. Just we have to draw that. So but PNP, it is coming towards the base. But in NPN it is arrowhead is away from the base. These are the symbols for this one. Then our next 11th VSAQ is 11th very short answer question is define the amplifier and amplification factor. See, olden days and these days also we are using the amplifier. Amplifier is, the role is always, it is strengthen the signal. If the signal is very poor, what is that role? It will become strengthened and we will get the clarity, quality and all these things. Then how to find out the amplification ratio? It is the output potential by input potential. That is called the amplification factor. A equals to V naught by Vi. V naught by Vi. So this is the amplification factor. Then our 12th question is, in which bias can a Zener diode used as a regulator? In reverse bias condition, already I said, only in forward bias it is acting like PN junction diode only, but in reverse bias only it is having the sharp breakdown voltage and it can be used as a voltage regulator. That is the 11th question. Then our 12th VSAQ is, this is 12th only, which gates are called the universal gates? Which gates are the universal gates? Gates means not our buildings and that gates. Here in electronics they are using the gates. There are different types of gates are there. OR gate is there, AND gate is there, NOT gate is there. Then NAND and NOR gates. Our answer is this only. NAND and NOR gates are the universal logic gates. Why these are the universal logic gates? With the help of the NAND and NOR gates, we can construct any type of gate. If you want OR, we can use NAND and NOR gate. If you want AND gate, we can with the help of that we can construct. So that's why NAND and NOR are the universal logic gates. When we are going through the truth table, for NAND gate, A and B are the inputs, A dot B are the output. See, 0 into 0, 0, but 0 bar is the 1. 1 into 0, 0, 0 bar is the 1. 1, 1, 1 into 1, 1, 1 bar equals to 0. This is the truth table of NAND gate. This is the truth table of NAND gate. Like that, NOR gate also we are taking A, B, A plus B bar. 0 plus 0, 0, 0 bar equals to 1. Then 1 plus 0, 1, this is 0. This is 1 bar equals to 0. 1 plus 1, 1 bar equals to 0. So anyway, NAND and NOR gates are the universal logic gates. Thank you.